All right, so we've done these multiple choice, quite a few of them before, but I just want to kind of review. So for this one, the average speed of the object in the tape. If you notice that we've got 17.5 centimeters covered in 2.5 seconds. And when we actually work that out, it ends up being, I think, about 7 centimeters a second. Let's just double check. Yep, 7 centimeters a second. That'll be the speed. Now, the velocity graph, let's just be clear. So first we've got a steady velocity, then our speed increases, then it decreases to a faster steady speed here versus here. So that gives us choice A. And if we look at the acceleration as a function of time, I'm just going to go ahead and actually copy this graph here. Whoa, that's a horrible copy, that is it. Oh, there it is. Good. So that's the velocity graph. Now let's look at the acceleration graph that would make that happen. So for acceleration, I would need totally flat at the ends, and then a positive and then a negative acceleration. So that would be choice A as well. And then question number 4, we want to know the speed of the object during this interval. So it does increase during the entire interval. Actually, no, it's the speed, the velocity. We could say it has a steadily increasing velocity. But as far as the speed goes, the magnitude of that velocity, at first it decreases and goes to 0, and then it increases again. That'll be choice E. Now, as far as the acceleration of the object, it is a completely steady acceleration, because acceleration is the slope of the velocity, which is a constant. All right. Now here, the displacement of the object would be the area under the graph, which when we add that up is going to end up being 0. If you really want to be strict, we could do like 1/2 4 times 2.5 with a negative here, plus 1/2 times 2.5 times 4. And when we add all that up, we're going to end up getting 0. Now, an object dropped off a cliff. How far does it fall in 6 seconds? At this point, we should really be fast with this. So 1/2 times 10 times 25. That's going to be 5 times 125. Is that right? 6 seconds. Sorry, 6 squared is 36. So I'm getting 180 meters. And then here, we want to know when the net force of the object is 0. This is an interesting question because we have the position. Now, when is the net force equal to 0? Well, the net force is ma, so we really want to know when acceleration is 0. So we'll take two derivatives. We've got 6t plus 1.5 is x dot, and then x double dot. We've got here 6 is the acceleration, so it actually turns out the net force is never equal to 0 in this case because the acceleration is always positive. And then number 9, this is an interesting one because we've actually set this up, but we haven't solved it. I wouldn't put this in your exam, but I just wanted to review it real quick. So we've got mg minus kv equals ma, but a here is dv dt. So we've got mg minus kv equals m dv dt. We can actually simplify here, so we're going to have dt over m equals dv over mg minus kv. So none of these work. Well, that one doesn't work. Let's see, mg minus kv dv. Nope, that's not going to work. Those endpoints are wrong, so we're left with these two. So we need to integrate from 0 to t on the t side and 0 to v on the v side. So A is the only choice. Here we got a 500 kilogram car accelerating, so we got 1/2 at squared plus v naught t. The initial speed 0. Let's get the acceleration. That's going to be 30 meters per second in 6 seconds, so that's 5. So 1/2 times 5 times 36. And that's going to be 5 times 18. That ends up being 90 meters. All right, so that's the first 10 multiple choice. We'll do the second 10 in the next video.